Hello, everyone, and thank you very much for coming to this presentation. It's a case study, a project that I've been working on for a few years now, and I was a member of a team. I will show you a little bit later. It's a very traffic-heavy website, and I think it will be very valuable for you to see how we addressed some things and what the challenges were in fact. Just a few words about myself. I'm working with PHP for a very long time. I think I started 2002, 2003, something. And it's my main development language. I've been moving to Python, so making new friends lately. But PHP is my main language. I also have a lovely 3-year-old at home, who's missing me quite a lot these days. My main focus is on handcrafting enterprise application, is because it's not only the enterprise part that's interesting, but also the way we craft it so that it actually fulfills the business needs. And during these years, since I've been coding, my role has switched from being a junior developer and doing mundane tasks more to an architectural role, and I absolutely enjoy working on large-scale applications. So if you need help with one of those, you know who to talk to. And something that I started about a year and a half ago was organizing the local PHP group, because sharing is caring, right? So it's not only the information that we have on ourselves, but also sharing it with the rest of the team. And all the above weren't enough. So last October, I started a PhD in systems engineering. I'm trying to work on something that combines systems engineering and artificial intelligence. A lot of the talks here at VOXXED Days are very close to my topic. And I will be happy to share more details with you if you want. Also, I salute the presence of a lot of people in the audience that already have finished a PhD, so quite an interesting audience, I would say. Okay, now moving on to a short outline of the talk. I try to be very schematic about it. So first, I want to introduce to you the challenge. What is it that we needed to solve? Then we will look at the enterprise architecture, how we thought of it on paper. And then there are some tricks that we learned along the way in these years. I will introduce them one by one. And at the end, we will have a look at the lessons learned. So, moving forward, let's start with the challenge. The actual project is about an airline company from the United States. You know, the US business world is like move fast and deliver things even faster. An ultra-low-cost airline, which started about the end of the 1990s. And they experienced a very, very big increase in terms of customers and assets. So they started writing code with old versions of PHP, but their code was constrained a lot by their tremendous growth. What's interesting about the customer is that their airport strategy is a little bit different. So they don't fly main airports, but they fly small ones. So they don't have a direct competition on most of the routes. If you are familiar with the travel industry, you would probably know what a GDS is. If not, I will tell you a little bit about this. So most of the companies rely on having the availability information handled by a third-party software. In the case of these guys, they wrote their first GDS in-house, and then they had to continually support this part of the business as well. The way they are selling tickets is through two main channels. One of them is the website, which poses the traffic problems, and the other one is a call center. So if you are, let's say, disabled, or you are in a location where you can't access the website, you just use the call center. and the call center will use a minified version of the main website as an application. So you will go through the exact same steps. Now, what I want to show with this funny counter is how much money these guys are making every second. So you will see the counter increasing and increasing, because this is how much money is flowing through the system. It's not a very trivial task to work like this. Okay, now, because we're talking about the challenge, this is how the system looked like when we first arrived. So they had a main data repository containing all sorts of data, like static data, availability, and reservations. We will talk a little bit more about each of them in the coming minutes. And what I already said, how they make reservations through a web interface and the call center, and also, of course, a back office to manage all this kind of information. But it was not as simple as this, but it was not very complex either. So you would imagine it was a nightmare to maintain and to scale, because everything was kind of centralized. I will not use the word monolithic in my in describing this. Now, they had real issues, and they had a lot of customers who wanted to give them money, but didn't have the necessary tools to take it. So they had quite a strict set of requirements from the new product. First of all, they wanted to center the experience of the customer around the destination. So they would be like, the company is based in Las Vegas, which is the most fun thing ever. And they wanted to bring in loads of people, that they already were, but they wanted to bring in even more, and center the travel experience around the destination. Like, not only selling plane tickets, which was the core of their business, but also hotel reservations, car rentals, and so on. And in Vegas, you can do a lot of things, so they are also selling tickets to various events locally. The second item on the requirements list was, of course, scalability. They didn't want to have another big rewrite in the next couple of years. And the most problematic thing was that on Cyber Monday, when loads of people were on their website, they wanted those people to be able to purchase things from the website, not just stare at some static pages telling them everything is overcrowded. Another problem was an extremely narrow delivery time frame. We had 1 year to change everything under the hood, maintaining the existing user interface, but change everything that was after it. And another constraint is better visualized like this. We had to do exactly what you can see in this small video. And I can assure you it's no trivial task. We do that on a daily basis for all our projects, right? But in the case of these guys, it was even more complex. So you can find a lot of similar videos if you if you go on YouTube and search for Arabs changing wheels while driving. So let's talk a little bit about the constraints that our project posed. You can see our customer was based in Las Vegas. We had the Java team working from Canada, and then some of the management of our team was in the UK. We had colleagues in Germany, and most of the development team was based in Romania. You can already see that the span is large, and this was a problem in itself, but we alleviated it with some clever developer tricks. The second problem in terms of constraints was the diversity of languages that we used. So PHP is our main language, but JavaScript played a very important role, and then we had all sorts of other things to accompany that. We migrated our automation infrastructure in 2 steps. We arrived at Ansible after fighting Puppet and others, and so on. So let's see how we address this. So you already understand we had something very complex on our table. So we divided 1 calendar year into 3 parts. First of all, we said we are going to work and deliver the booking path. So the core of the business, the part where you actually purchase things, we will deliver that one first. Not only that, but the second milestone would be the opportunity for the customer to have an online check-in. So work with the actual employees of the airline as little as possible. And then we would allocate a couple of months specifically for performance testing and improving what we implemented so far. And how we did that was first we took a lot of pens and plenty of paper and came up with this enterprise architecture. We said, okay, whatever the system is doing right now, we will consider it as a data layer, including the code that does certain functions. We would be able to call the existing code if needed or access the data store directly. It didn't really matter. We considered everything as raw data. And then we added, on top of it, content repositories written by the Java team in Canada, meaning that we would be able to deal with the content on a microservice level. But just imagine that the content repositories would deliver transactional functionality. The PHP team wasn't trusted that we would be able to do it on a transactional level, so this is why we have this Java layer. But the Java layer is doing a lot of interesting things and is talking JSON. JSON output from the content repository layer is very important because if we used XML, it would kind of consume a lot of bandwidth in the network. So JSON kind of minified those things. Now, the next thing that we said, everything that is high traffic, everything that is currently problematic, we'll put it in a separate bucket and address it differently. The back office, on the other hand, doesn't have all those performance problems, and we will be able to deliver it in a different way. Also, one important aspect was the security. So the back office would need to be more secure and less performant, whereas the customer-facing code and functionality didn't necessarily need to be ultra secure, and it didn't have so many users that were constrained to this thing. The only important aspect was the performance of the solution. And now some numbers. So on the front-facing part, except the Java machines, as you can see in this picture, we had more than 30 machines that got our end-to-end functionality from a customer perspective. And how they would be, in fact, light down, we wrote a very thin layer of PHP, which is here depicted as middleware, that would do the business logic of transforming those transactional JSONs from Java into very tiny inputs and outputs on the JSON level. And that middleware would be consumed by various clients. One of them was the website, which is a single-page application. If you don't know the acronym, a single-page application have one huge advantage. You get them in the client browser the first time, and then they stay there, and the only communication that happens is through those tiny JSONs to the middleware. And that's very important from a performance point of view, because the user will perceive the application as being much faster, even if it's not necessarily extremely faster compared to others. It's just the fact that you minimize the communication, and then instead of loading all those static assets and everything, you just focus on the actual data that is transmitted. Our data, because we were our own GDS, the availability information would be crawled by other customers. So they had own crawlers that were consuming our middleware. And then at the end of the day, everybody has a mobile application. So that was a third customer that we had. Now, everything looks perfect on paper, right? So if you draw all kinds of diagrams and boxes, all of them will look perfect, but the real world is a little bit different. So while moving to that enterprise architecture, we discovered some things that greatly improved our performance. The first one was the fact that we need to have a cache layer that was sitting very close to the customer. What does it mean? As close to the customer as possible. So the browser would load the SPA first, right? The single page application, the big JavaScript fancy thing. That would immediately talk to the cache. So if the cache would have been considered on the data level, we would have to go all the way through the stack. Now, having the cache on top actually asks for data duplication. So from these types of data that you see here, I told you we will be talking a little bit about them. You can see we had availability information. Is the flight fully booked or not? Which seats in the plane are booked? What hotels are available, and so on. Reservations was the information about past bookings. And we have static data. So the actual flight seat map is not changing. You have the actual plane. You know exactly how the seat map looks like, right? If you have a hotel, it rarely changes its picture or its description. The only thing that is changing is the availability data. So what we did was take the static data and move it close to the user browser. It's a task in itself, and it's the subject of an entirely different presentation, if I may. But how you do that? But this is something that we absolutely had to do, because now the cache could be hidden under a varnish, and then the SPA could access things almost instantaneously, let's say. The second trick was to do a lot of things at the same time, which is not very simple to do, because when you make a booking application, you have to go from one step to another. So what can we do in parallel? We can do a lot of things, but from a PHP point of view, PHP is not multi-threaded. So we have some libraries. One of them is CURL, which is written on top of the CURL that you have in Linux. And it has the possibility to use curl multi, which means you can launch multiple requests at the same time, and then you wait for the slowest one to respond, and that's your total communication time. And you can use this one with async processes. Now, I think everything is better if you look at it on a picture. So let's try to do that. Once the user is selecting the flights, we have an event that says, okay, the flight choice was completed, and then everything else is being searched in parallel. So now that I know that the traveler is arriving on, I don't know, May the 10th and leaving on May the 12th, I can search for available hotels, vehicles, or shuttles if you don't want to rent a car. I can immediately load the seat maps for those two specific flights that the user chose, and I can look at the tickets for various Vegas events, right? Now, the slowest one, which is probably the hotels, will dictate how long this takes. And when the slowest one returns, we can, if we want, aggregate prices. We had some requirements that in some cases we need to show a full price for an entire package and not individual prices. So by using this approach, we had to combine numbers from the hotel price and the flight price and so on. So we had an additional processing step. Now, once this event completed, the user interface would be updated to the next step. And then when the user would be fetching the hotels will, results and availability and static information would already exist in cache. In our case, memcache, but this is not something that we need to tie up to. So this would be extremely fast. All of the next steps would already be in memory. And the update of the user interface is taking advantage of the fact that the search is already there. And let's say you don't yet have the information in the cache, you just load the spinner, right? But you don't have to wait for, I don't know, products to be loaded. So you don't wait for everything to happen. The third option that we had, we needed to have, was using fixtures. And fixtures are mostly an opportunity to discuss the contracts between components before we actually start writing code. So we would sit at the same table or use Skype for a long distance call, and together we would draw the specification of the JSON that would be exchanged between components. And the biggest advantage of having this is that you can handle the negative scenarios as well in the beginning, and then everybody will go and hide and write the code. By that I mean developers working independently on a Canadian time zone and on a Romanian time zone. So you only need to be together in the beginning and discuss the contract. Another advantage was that on my machine I could only run the tests that would be related to the component I was currently working on. And when moving to a different component, I didn't need to have the full stack installed on my machine. I could only focus on getting the job done for one particular item. And I know that in development, communication is key. So having communication happen in the beginning before writing code actually made us faster, even if it looked like we would spend more time in meetings. But the gain was significant. So if you want to visualize the fixtures, you would just say, okay, this is the component, this is what it needs to do. And you would actually hard code, let's say, JSONs for all the inputs and the outputs of this particular component. So this is the fixture. Nothing fancy. And another advantage was that when running automated tests, we could have a set of fixtures for the happy scenario, another one for something that is breaking, and so on. So we would be able to automate the entire run of the tests. Now, the next trick is the one that is not very well known, but it helped us tremendously in a couple of situations. Does anybody know what 204 means from there? Yeah? Yeah, exactly. It's a status code from HTTP. And I put a link there for people using the presentation later. It is a success code, so this is very important. HTTP status codes are divided into, let's say, several groups, and everything starting with a 2 means a success. Now, this requires trust. So if somebody comes in, makes a request, and I return a 204 with a success status, it means their trust is put fully on me as the receiving component, that I will be able to do my job properly, right? Another important thing about 204 is that you cannot return anything in the body. It has to have content length 0. So the whole trick is, this is a convention, right? As the backend, as the receiving component, I am acknowledging the fact that you made the request. I have your request, and then you can continue on with your life. In this case, would be, okay, go and update the user interface, because for sure you will find the results in the cache a little bit later, in a few seconds. Right? So you can continue processing, let's say. So going back to the diagram part, you can see, for example, when the user initially made the search, they would say, okay, I want to fly from New York to Las Vegas, right? And they would post search data. And in this case, the framework is Symfony. It's not very important. The middleware would immediately return a 204 no content, saying, yes, I acknowledge the fact that you made this search. Thank you very much. And you can see that the UI will only communicate with the caching layer after this initial search. So after we return a 204, the actual PHP process, in our case PHP, doesn't die. It continues working. So what we did was, okay, acknowledge the request, have the UI refresh with the next page, load all the static assets, you know, all the other things, and we would, in fact, go to the Java service and say, okay, now give me availability for this interval. In here, you can see we have an initialize of a manifest. Manifest is the user search, the cache with the results of that individual user search. So we'd have like a session ID manifest, right? That is written into memcache, and related to that session ID manifest, we cache the flight results. What happens is that while we do all that search and put data in cache, the UI would be able to update to the next step and load the, I don't know, the logo, the CSS, the JavaScript, everything at the same time as we are actually doing the search and writing the data into the cache. And what the user will see, if the data, if our part of the contract is not fulfilled and we don't write anything into the cache, it will not be a user error, right? It will not be a severe error that the user cannot continue. We'll just say, okay, we are retrying, and it will, all of a sudden, error management will become easier. So we will not lose our customer. If something goes wrong in the backend, the customer can start the search again, right? It's only going one step backwards. This is very important because if the user perceives the application as being fast, and if the user trusts they can recover from whatever they did, then the user, this will build actually a brand identity that you are trustful. The 204 trick can be applied in other situations. So going at the UI level and discussing between components is one aspect, but what we discovered will be useful is to do batch processing. So there are certain things that we need to do first. We need to check that the call is actually allowed to happen, right? If the callee doesn't have enough permissions, we would reject it at this point. And then the data that we received from the user, is it valid or not, right? Because if it's not valid, I will not return a 204 not content. I will return a different kind of error. But once the permission check is successful and the user data is valid, then the return is instant, and I'm able to process the batch. And if it takes me 20 seconds or 1 minute to do that processing, the user will not be waiting for me. One thing that we used this for was logging. I showed you that we had like 30 machines running in production for this. So it was very complicated to actually do debugging. So what we did was we wrote a logging system that would function on the 204 trick. So you would send the data that you wanted to be logged from, it doesn't matter from what machine. You would tie it up to the manifest, to the user session, and then the logging component would take care of it. And this is an aggregate of a user search. So you can see we labeled items based on the components that sent the messages to the log. And you can also see the duration of one event, because we would receive like 2 different events, right? The start and the end. And we are already able to visualize the duration of this action. So in this case, you see it took about a second for something to happen. But in this time, actually, if you look here, it's even better. You can see all the green items start at the same time. And you can see the hotel is always taking the longest. But all of them are happening, and then everything is put into cache. So the event that started with user selecting flights, and then user finishing loading the next page, you can see how long it took. So this was of great help because we could actually move this in production, so have specialized logging in a production environment. The 204 trick is not depending on the environment that you run it in. So instead of turning the logs, the application logs, to verbose or something, and then trying to figure out what happened from those logs, and not having that in production, this is a tool that we were able to use and sample certain users and see if there were any kind of problems. Okay, the fifth trick are silos. Silos are mostly an architectural thing. So normally in IT, when you say silo mentality, it means that the marketing department and the sales department and the developers don't talk to each other, right? Each of them is a silo. This is not our notion of a silo. So in our case, the silo was the entire setup of servers that were needed to execute the end-to-end functionality. So in our particular case of the application was the Drupal. I will not insist on reasons for using Drupal, and JavaScript SPAs, meaning the front end. Then the backend, the middleware, composed of the PHP services, and the cache, right? Everything that was related to data is not part of a silo. So if you take the entire application stack and horizontally scale it, all of a sudden, the world will be much better. Why? Because you can make very interesting changes inside one silo. And I have some slides a little bit later about that. But first, let's look inside the silo. You see here that the load balancer, the technology chosen for our customer was F5, which is kind of an expensive choice. There are more interesting ones, including using the DNS itself as a load balancer, but that's a different story. So from that load balancer, you would go into Varnish, and Varnish will take care of making the request. So in this case, you can see that if the user came in on the home page, they would load the Drupal and single page application. All the other requests, as we said, were to the cache directly. So in this case, you wouldn't need to traverse the entire stack. Now, Drupal would make the call to Symfony to make the searches and so on, right? And how did we actually put data into the cache? Well, we had availability information from Java, right? We got it here. But we enhanced it with static data. So the front end would not make two different requests to the cache. One to get the static information, another one to get the dynamic information. We would do that ourselves. And then the single page application would just load the results. They would never know that the results were combined by us at this point. And the static data was already present here, as I showed you in the previous trick, because we made sure it was part of the silo. So what we can use silos for? Well, first of all, we have different caches inside each silo. So if one day you would like to migrate your cache from Memcache to Redis, this is how you do it. You raise another silo and only make adjustments to the caching layer and direct about 1% of your traffic to the second silo and see if it works or not. And if it doesn't, you have a fallback mechanism because your existing application is already installed and running. If everything is okay, you just direct 100% of your traffic to the next silo. Not only the actual cache technology that you use, but also what you put inside the cache can be A/B tested like this. So what exactly do I need to put inside the cache for everything to work very fast? We might be very smart and figure it all in our head, or we might want to measure it. I think by measuring, we achieve better results. And now the interesting part. A/B testing with silos all of a sudden becomes very natural. Because normally in A/B testing, you install some JavaScript library, or you do an if-else in the code, or you make a configuration item that will decide what exactly, what version are you executing, right? But this is making changes inside the code, and is very dangerous and error-prone. But if you work with silos, you can A/B test your code your technology choices, your infrastructure, anything that you want. Because one silo delivers the end-to-end functionality. So you just don't care. If you want to migrate from PHP to Java, you can do that. You write the functionality in Java or in Node.js or whatever, and you put things in a new silo and start measuring with real data. Because if you put like 1% of your traffic into one silo, the website will be up and running, and you will be able to measure with real production data. For the US, this is a very friendly slide, right? Their problem was a geographic distribution. So we only had like 2 silos, but for large applications, you can geographically distribute your machines to execute that information. Why? Because you don't have any kind of data inside the silo. So communicating with the data layer is separate. And something very interesting is how you can do live upgrades. So this is like high availability. You have, let's say, currently running a combination of the code that totals to version, I don't know, 16 something, right? Because you have so many components in various languages, you need to install all of them. If you want to make a major upgrade, you do that on a different silo. You put the new version of the code and slowly move traffic to it and see if there are problems. Because if something bad happens and you have a problem in the code, without silos, you would need to revert everything, and then your website will appear down, right? Your maintenance window will be longer, and so on. In this case, you don't have a maintenance window. You don't need it. And if there is a problem with version 17.1.1, what you do is close the traffic from the traffic controller. Don't send anything there. Come up with a patch and put it in a new silo. And the second one, you just kill it. It's virtual machines, right? Nothing bad. Okay, so the talk is the time allotted is shorter. I want to also have questions, so I will just summarize the lessons learned. First, one, static data, put it as close to the user as possible, and make it a cache in itself. Execute as many things in parallel as you can. Use fixtures to address, in our case, the geographical limitation, but also for the entire test suite. 204 trick, I hope you find it useful. If you forget everything about this presentation, try to remember the 204 trick, please. And silos are the actual power horse for real A/B testing. Thank you very much. Any questions? Yes, please.
Waiting for the microphone. Okay. Yeah, I have a question. I like the 204 trick. That's the thing I was going to ask about. Cause, is it a way of sort of like telling a convenient lie? Because you're kind of going, yeah, it's going to succeed. Don't worry about it. And then later on, it could actually fail. Because I could think of some circumstances in sort of applications I've worked on where it would be useful to go.
Sometimes it happens that the communication with the data layer, so everything, something can go wrong in that part. But the user doesn't perceive that as being his fault, right? It just says, okay, there's a glitch in the metrics. I will just try again, search, right? You turn an application error, like a potential server issue, into something that is recoverable by the user. And it does happen. Systems are not perfect, but at least you retain the customer instead of driving him away from your application. Does that answer your question?
Yeah. Do you have any ways of like reporting errors sometimes? Because you might want to later say, well, it didn't actually work. Or do you just, is it always for situations where you go like, it's probably most likely going to work, supposing there's no like any bugs in the code?
Yeah, absolutely.
Okay.
So when developers are developing the application, do they ever run the entire site, as it were, on their machine? Because you said you would work on one part of the system only. So is that common? Is that a common practice with microservices? Or
to run only one component or run the full stack?
Run the full stack on your machine, so run the entire airline website.
Absolutely.
Okay.
This was several years ago, and Docker wasn't as popular as it is today. So we didn't have a combination of Docker containers. Instead, we had virtual machines doing the same job. But the entire thing of fixtures is that you can replace the other component. So instead of raising another virtual machine or a Docker container, you plug in the fixtures and you work with the fixture set. But of course, as a developer, you need to be able to run the full stack. And we did that. The part that is very complex is when you explain a JavaScript developer that's working on the front end that they need to have all sorts of craziness of PHP or Java on their machine. So this is alleviated by using fixtures.
So most developers actually use the fixtures only certain, so other developers, when they need to test the entire site, would bring it all together?
Yeah.
Oh, okay.
Exactly.
That's pretty cool.
Any more questions? I'll be around on the hallway, so if you're shy, you can come later.
In your silos slide at the end, you were deliberately keeping the data out of the silos. They were sort of throwaway
Like this.
environments. Yeah, I mean, if they're geographically disparate, then the problem presumably is that it takes quite a long time for Europe to call the data center wherever it is if it's on the other side of the planet. Do you just get over that by the fact that your entire app is effectively this sort of stateless and requestless kind of?
Exactly. Thank you very much for the question. The real advantage of the silos is that the cache is inside the silo. So all the static data about whatever you're selling, the seed map and everything, is already geographically located where you have the silo. So the only thing that you get from the data layer is availability. And you can minify that up to a point where the size of the data that travels on a geographically distributed environment is smaller.
And do you prime the caches then, or do you just let them fill naturally? Because otherwise, initially, the first time you're going to hit it, it's going to be very slow if it has to populate the cache.
Filling in the cache in the various silos is a separate talk that I'm, in fact, working on, so I'm just not bragging. And you'll be able to see it in about a month and a half. So that's a completely different discussion. The data layer is always a pain. So if you can minimize, working with it is always great. And if you've been to the CQRS talk this morning, you would already find out that some of the things that I show here can be better explained using CQRS, where all the data is kind of hidden in a different place. So interacting with the actual data is a challenge in itself. But if you can make this separation between what is static, what I can have with me, and what can be even stale data, let's say, right, because it's cached, is one thing. And the actual availability is a very tiny piece of the application. So then geographic distance is not that big an issue, let's say. Okay? No more questions? Okay. Thank you again.